Hello, this is Journey to Oscillations by Nathaniel Grange. What is in this lab? In this lab, the viewer will observe the predicted and observed motion of weight slash mass attached to a spring. In the slideshow, I will utilize the tracker software to capture the observed motion of the weight attached to the spring, and I will use GlowScript to create a predicted, more calculated model for the observed experiment. There will be graphs to show the correlation to illustrate the results of change in energy to be zero. Things to know. A law that should be understood is Newton's second law of motion, or describes force acting upon an object. Newton's law states that the acceleration of an object is directly proportional to the net force acting on it, inversely proportional to its mass, F equals ma. In terms of oscillation, it governs how the restoring forces from displacement and mass determine the object's acceleration affecting its oscillatory motion. Things to know part two. The energy principle states that energy is conserved in a system, transforming between different forms but remaining constant overall. It underpins fundamental laws of physics describing the behavior and interactions of particles and fields. Energy can neither be created or destroyed. The total change in energy for a system equals to the change in kinetic energy plus the change in gravitational potential energy plus the spring potential energy. Here's the analysis of the video. As you can see, the points are all oscillating above the axes, showing different points as it increases and decreases in the same region. Some initial conditions that have been found or slash observed is that the initial time is zero, initial velocity is 0 meters per second, initial position is negative 0.113 meters in the x direction, and in the y direction, negative 0.633 meters, and in the z direction, 0 meters. The mass is 0.402 kilograms, and the length that is relaxed is 0.7 meters. And this the constant for I guess breakers is basically 6.83 newtons per meter. This is a computational model. So the computational model basically showed that I was calculating energy and changes and editing everything for like basically finding its values using the utilization of the initial values that I was given from the analysis of the video. Here's the comparison. As you can see, in the bottom right, this is basically the graph of all graphs put together on top of each other. And you could see through all out everything, the change in energy is constantly zero, while every other thing like the potential spring energy and the potential gravitational energy and the potential kinetic energy, they're all oscillating, but at each point that they all three intersect is when delta E is basically overlapping. And that's because they all cancel each other out to create delta E, which is a constant zero. What does it mean? For your model system, is the energy principle satisfied? Justify your answer by discussing briefly your plots of energy changes. For this model system, the energy principle is satisfied since delta E is equal to the zero throughout the whole graph. Besides delta E, delta K, and delta universal gravitational or potential gravitational, and basically delta potential spring um energy are all oscillating at different points and intercepting each other on the line of delta E. This means that energy, no matter how it's transforming, it is still being constant and being conserved. Using the data you obtained in tracker, make two separate estimates of oscillation periods. First, by estimating the period of oscillation from the X position data, and the second by estimating the period of oscillation from Y position data. Compare the two data estimates and discuss. Since the spring constant is not the same in both the X and Y direction, it caused a little slight difference in the oscillation periods. I estimated for the X position, it would be around 1.668 seconds. And for the Y direction, I estimated it would be around 1.52 seconds, 27 seconds. Thanks for viewing this presentation.